Hi everyone, it's Dr. Custer. Today we're going to do a lecture on project dataset and data entry principles. This lecture was created by Dr. Bill Corser, who is the Director of Research at the Michigan State SCS, and I just added some additional information and some examples from projects that you guys have done. So let's get started. Learner objectives. To identify at least 3 standard characteristics of most workable project datasets. To analyze the major principles of creating a standardly structured project dataset and codebook, and to evaluate at least 6 of strategies for preparing your final working project dataset for analyses. So why do you care about your dataset? Well, first, having a tidy dataset will enable you to better answer your project questions. Having accurate data means that you will be able to answer your question more precisely. So garbage in, garbage out. That's basically saying, the quality of what you put into your data set will reflect the quality of your final analyses. So it's important that you do this correctly. The kettle of stew analogy, sometimes you collect so much data and it's just all murky and there's so much. You need to really make sure that everything's cleaned, it's precise, it makes sense. And we're going to go through that throughout this lecture. The other reason, because you'll minimize how much work is required of those of us helping you collect it, enter it, clean or analyze it. Dr. Bill Corser, of course, is one of those people, Sam Wisniewski at the SCS, and myself. And we all have limited time. You guys know we're all busy, so we need all these to be done properly. So let's go through some tidy dataset principles. Be very clear what key variable or study ID number will be used to identify each separate person. So this is just that first column that you're going to insert and put study ID or respondent ID. It's not that complicated, guys. If you have 50 paper surveys, you can just label them 1 through 50 as you're entering them into the data set. Now, SurveyMonkey and some other programs do create randomized respondent identifiers automatically. So if you're downloading from there, you will not need to create a key variable. Ensure for most types of projects that each horizontal row is a different person, respondent, record, or case, whichever you would like to call it. And then ensure that each vertical column in your data set is a different, clearly named variable. So what you collected. Clearly named, for example, age, years at survey versus just age. So here's an example data set created by Dr. Corser. Here's that study ID number we were just talking about. They started with 1001 and went on. They collected some data about a lab. Here's diabetes meds. You can see 3 different meds were used. Date. Now, the full date was not given. The year is listed as an X to show that full date is an identifying factor, so you do not want to put the full date. Just like you wouldn't want to put any HIPAA or PHI on your data set. Clinic site, looks like there's a few sites. Age is just age. And then gender, here we have 1 and 2, so perhaps 1 equals male and 2 equals female. So here's an example. Again, ideally your variable headers should be self-explanatory. And then you want to maintain a separate code book. Now this explaining names and values for each original and newly created variable. So you can use your survey as your code book. You'll just want to make sure that each response has a number listed after it. So I will show you an example of this in a few slides. Some more data set strategies. Be consistent with your value coding decisions. For example, if you decide 0 equals no and 1 equals yes for a question, then throughout the whole data set, for all the yes-no questions, 0 will equal no and 1 will equal yes. Another example, for gender, you could do 1 equals male, 2 equals female, 3 equals transgender, and 4 is prefer not to answer. If you have a diabetes question and they're on a few different medicines, you could do 1 for regular insulin, 2 for metformin, 3 for glyburide, and so on and so forth. Another note, you want to maintain some sort of project record book regarding decisions, if, for example, issues such as missing or unclear data, or etc., if applicable. And we'll go through this in a few slides, but if you have missing data, unclear data, you're going to want to keep track of some sort of notes of what you did with that data. Now, a note on non-mutually exclusive categories. Let's say you're going to ask age in categories, and you put, please choose your age range. And you have 20 to 30, 30 to 40, 40 to 50, 50 to 60. Now, what if the person's 40? Well, they can't choose two different ages, right? So that's an error. So you want to make sure that your categories are mutually exclusive. You want to put 21 to 30, 31 to 40, 41 to 50, etc. So it makes logical sense. All right, so this is an example of a code book from a Schweitzer project I'm advising on. You can see each question is clearly labeled, and then each response has a number that corresponds to the number on the data set. The formatting is not important. You don't have to have certain, symbols or anything like that. Just make sure that everything's coded correctly. Now, just a couple slides on how to create vertical column labels in Excel. I know a lot of you guys have advanced Excel skills, but for the people that aren't aware, this is just a quick way to make it look good. So what you're going to do is you're going to enter all your variables in the first row like you normally would on Excel. You'll note there's no spaces. I use underscore between words. Then you're going to highlight the entire row, which is indicated right here with the blue arrow, and click the orientation button on the alignment tab. So after font on mine is alignment, and then right here is orientation. When you click on this tab, there's going to be several choices that come down. I chose rotate text up, and then you'll see this. Now the columns might be pretty wide, so you have to hit format column width. And another note is you can make them, diagonal, however you want to do it. It doesn't have to be up. So just note that each variable must be in a separate column. For example, blood pressure, you can't just do 120/80 in one column. You have to do systolic blood pressure and then diastolic blood pressure, so they can be averaged separately. Another note is, if you have a pick all that apply, for example, if this question was, what barriers to access do you face for care, you could have transportation, financial restraints, childcare, etc. If they pick multiple, they each have to be recorded in separate columns. So let's say they do pick transportation, you would put a 0 or 1 depending on what you chose. If they said yes, 1 here. If they said yes to financial, there'd be a 1 here. If not, there'd be a 0. So that's how you do separate columns. Absolute data set sins. Using the same study ID number for different persons, obviously that won't compute properly. Multiple variables stored in the same column, exactly what I was just talking about. I used to let residents send me data with multiple variables in the same column. For example, it would say 1, 2, 3, or 2, 4, 7. And it took a lot of work to separate it out, so I just want you guys to do it right from the beginning. Same variable stored in both rows and columns, usually not an issue. And then entering numeric data in a string variable column. String data is just text-only data. The main point here is you can usually get away with numerical data with a code book. But if there's something that can't be coded, you're going to want to choose. You're going to want to just make sure it's all text and don't put any numeric data. See, the point is you can't have both text and data in the same cell. So data entry. It may be best to assign a final master study ID to each person as you're entering them into the data set. Like we talked about, if you have surveys, you could just put 1, 2, 3, 4 as you're entering them. If you are doing paper surveys, take a highlighter and just cross through each page after you've entered it to keep track. You want to save and rename your updated data sets frequently. So many times you have to work on your data set multiple times. And then you want to save as each time with the date. And then, it may be helpful to create a blank field variable at the end of the data set for any kind of qualitative comments or notes, any data enter notes, etc. All right, as far as data cleaning, do some initial review of your raw data to examine for missing data, puzzling response patterns before you start cleaning. Now, puzzling response patterns I've seen throughout the years on some resident projects. For example, if you ask a female, do you have children? And she says no, but then the next question says, if you do have children, how many do you have? And she writes a number, like 8. You have to make a decision. What are you going to do with that? Or what are you going to do with that no? What are you going to do with that 8? How are you going to resolve that puzzling response? All right, so here's an example of puzzling data from a resident project I received a few years ago. This resident had not sent me the individual responses they recorded. They sent their composite data. So right away I noticed that these numbers didn't make sense. If 26 patients had been referred to counseling, then why were there 29 responses to question 8? And then if only 19 had taken their children, why were there 28 responses for questioning 9? So I had to go back and figure out what was going on. So I went through all the individual data, and the people that had answered, no to question 7 were excluded from 8 and 9, etc. So after, I reanalyzed it, we were able to get the accurate totals. So data cleaning. You always want to retain a separate electronic backup copy of your raw data before starting. So that makes sense. Save all the entered data before you start cleaning anything. Save backup copies of working data sets with different dates and the file name, just like we talked about with the data entry. You want to maintain an ongoing electronic record of all data cleaning decisions. You update your codebook and data records if you change anything. For example, renaming your variable headings or combining anything, etc. And like I said before, if you make a decision to remove or delete some data based off puzzling response or whatnot, you need to write down what you actually did. Take notes. So what about your data analysis choices? You should discuss your data analysis plan with your PI, your mentor, the study coordinator, myself, but most of the decisions will come later. The analytic procedures that you and your analyst may decide to use will often depend on what you actually find in your clean working data set. So that is something that you will work on before and at the time of analysis. For now, emphasis is really on having a tidy project data set, as tidy as possible, and your goal is a standardly structured data set. So here's Dr. Custer's contact information at the statewide campus system. I wanted to make sure I included that, and that actually might be the old logo. I apologize. If you have any questions, please reach out to me with anything. My email's there and my cell phone number. I do prefer text or email. At this point, most of you seniors are finishing up your collection. Once you make your data set, we can decide together if Dr. Custer or the SCS assistance is needed, and then fill out that Scholarly Activity Consult request form on the SCS website. So that's the end of the lecture. I hope you guys enjoyed it and have a wonderful day.